Hey, it's Steve. I wanted to do a short video today on some really interesting weather happening in the northeastern Pacific. What you're seeing here is a view of water vapor imagery from May 27th. And basically what you're seeing here is a plume of very warm, moist tropical air coming up from the deep tropics, wrapping up into this area of low pressure here in the northeastern Pacific. At the same time, this orange and red shade here indicates cooler air and mainly much drier air coming in here from the Arctic areas here in the Bering Sea, getting pulled down and wrapped up towards the center of this low, which is sitting right here. There's also another low pressure that's kind of cut off, and we'll talk about that here in a minute as well, down here southwest of California. And so what's interesting here is how this storm evolves. Right here at what you're seeing right now is a storm at peak intensity. A lot of colors here in the darker blues indicating a lot of deep moisture and convection. So what you're seeing is a lot of rising motion here, and this is allowing the air pressure to fall at the surface. With all the air rising up through the column of the atmosphere, it's pulling in air at the surface and causing this storm here. And so as we kind of scrub through here, what you'll see is the storm really get wrapped up. And so at this point here, the storm is still pretty much holding the same intensity that it had, but you can notice now at this point there's a lot less of the blue, darker blues and deeper convection now near the center of the low, and the overall supply of moisture to the center of the low is kind of getting stretched out. And so at this point, the storm is losing that feed of warmth and moisture it needs to get stronger, and so it's not going to be able to strengthen anymore at this point in time. And as we go further along here, that supply of moisture gets kind of further constrained, and you'll notice the deeper moisture and convection is now farther and farther away. The low center is down here, and all that deeper convection and moisture is up here well to the north and northeast of the low. And so from this point on, the low is starting to weaken. And so at this point, the pressure at the surface will start to rise, and this causes a lot of interesting things to happen. And also there's some terrain interaction too, as the low kind of nears the coast of Alaska as well as British Columbia, and you have complex terrain here, which is kind of inhibiting the airflow as well. So the combination of you have all this air flowing towards this point where this low is, and now there's not as much air rising from the surface upwards, and so the air kind of starts to pile up in that area, causing the pressure to start rising. And then also the airflow is being inhibited by the mountains along the coast here. And so this causes some really interesting and very pretty complex motions, and you get a lot of wave instabilities. You go from this more smooth laminar flow to a lot of eddies start developing as the flow starts to break down as the pressure rises, and the flow hits some of the terrain along the coast as well. So let's just go through and watch this whole animation from the start, and you can see how everything evolves as this low pressure steadily weakens and all these complex eddies develop along and around the center of the low pressure. And so from this point on, you really see some very nice, pretty eddies starting to develop. A lot of instability there along the perimeter of the low. And the low is much weaker at this point. So basically, the air is no longer rising at the center of the low nearly as much as it was. And so the air is flowing in at the surface faster than it's rising up through the column of the atmosphere. And so it's piling up and causing all kinds of very, very pretty instability there. You can see the same exact thing in a cup of coffee. If you take some coffee, you pour some cream in there and you stir it, you'll get a nice banding effect that looks very much like the low when it first started to occlude and first started to wrap up. And then if you leave your spoon in there but stop spinning it, stop stirring it, you'll see a very rapid breakdown of the flow and all these eddies developing, and you'll see almost the exact same pattern in your cup of coffee as what you're seeing here in this low as that flow starts to slow down and break down. And the other thing that's interesting here is you have this area of low pressure here off the coast of California and Mexico, and it has been stuck here for a number of days. And then as this low pushes this is basically also a cold front here, and that's pushing towards the east southeast, and so this air mass back here is more dense, and it's going to give this low a kick and finally get it to move eastward. So that's kind of cool as well. You'll see that as this air mass in front hits this cutoff low here, it's going to finally give it that kick to move eastward. Because at this present time, before that front gets there, There's just nothing to move this low. The low is just spinning and spinning and spinning, and there is just no flow in the atmosphere, otherwise around there to help push it eastward. So once this front hits the low, it kicks it eastward. This has ramifications for the whole pattern eastward across the country as well, as this low moving towards the coast of California is going to cool the west coast and the southwest, and it's going to shift the hotter pattern that's in place there now towards the center of the country, which has been cooler lately, and so you're going to see the whole pattern shift eastward with time. And the core of the hot weather gets shifted towards the plains, and the west coast trend cooler as this low moves in here the next couple of days. But really just an interesting pattern. It's just really pretty to watch a deep low pressure occlude like this, and weekends you get some really pretty flows around it. It's this really beautiful instability developing around the center of the low as the whole flow pattern breaks down with the weakening of the low pressure area. And you see this same pattern in the North Atlantic sometimes. And again, in the Gulf of Alaska, this is very common to see this kind of pattern as these lows come up here and kind of die, because they kind of get stuck here, by the terrain to some extent as well. And you tend to get these lows that kind of just sit there and spin and weaken. In the Gulf of Alaska, very often you'll get a series of lows coming up from the southwest and coming up here and just dying and cutting off and doing this one after the other frequently. And so it's just a really pretty area to watch low pressures kind of die, because as they go through those weakening phases, they really just produce some very beautiful flows in the atmosphere to watch. So it's just a neat thing to see, and so I wanted to share that with all of you, and thanks for watching. Bye.